Welcome back to Arizona Longtails. My name's David and I'm here with the Rumblebee. And what we got is the Duromax 999 and a long overdue video on how to make the electronic throttle function throttle by wire or throttle by cable, even though the carburetor functions as throttle by wire. You can see here, got a paint scheme on it, matches the boat. We've got almost a year with the motor, but we've only put around 6 hours on it. Been mostly doing catfishing, so we're not putting as many miles compared to bass fishing. We'll go through the back of the electronics. I took off the plastic cover here so I could see the digital display a little bit better. It's a black panel and a red display, and sometimes in the day it was kind of hard to see it with some glare. You know, this toggle switch I added, I'll show you the diagram on how it got installed or why I got it used. This is your speed control, which is still functional, and I'll show you how that toggle switch kind of comes into play with that. And then I'll show you how the cable goes and works with the potentiometer to regulate the RPMs. So we could start with the basics of the schematic of the engine. So you got the ECU, it's what regulates your display for the RPMs. It controls, there's a wiring for your start button to start and kill the engine. There's wiring that goes to the throttle that regulates the RPMs in relations to the speed control knob, which is a 5,000 ohm pot. So that's once we got the engine and we figured out what resistance the pot needed to give feedback to the ECU. The speed pot, once we got the engine, we read the resistance, and it's a 5,000 ohm pot. So it goes from 1 ohm to 5,000 ohm, and that's how the ECU knows what speed you want it to run. So at 5,000 ohms, it would be minimum. At 1 or 0 resistance, it knows you want full throttle. So this is the stock setup of an ECU, and we could go through what we tied into to be able to still utilize the stock panel if you wanted to as a backup option, and have the remote control, and then how we're going to set it up to be a throttle by cable rather than throttle by wire. So if we want to look at what a hardware is actually inside, this is what a pot looks like. Very low voltage goes in, and then the resistance could vary from machine to machine. So it could be a 100 ohm pot, it could be 1,000, it could be 10,000. So they utilize a 5,000 ohm pot. So we had to find a system that had a 5,000 ohm pot and that could regulate as a foot pedal or a throttle would. We would almost want something that springs back. So this is a pot potentiometer. This is a rheostat, which functions the same way, but typically they're a little bit higher voltage or amperage going through them, so that's why they're a little bit more heavy duty. And I brought it as an example of, so you can visually see what's inside the casing back here. So you have a brush system and a swiper. This one goes up and down as you turn the knob, and that changes the value of the resistance it's putting out at these two leads, and the ECU is reading those values. So here, if it's at the halfway setting, it's going to be reading 2,500 ohms back to the ECU, and it's going to know you want half throttle. If you go full throttle, which would be given its minimum resistance, it knows it's getting full voltage from its output at the purple and yellow and green wire. It knows that you're wanting full throttle, and it'll adjust the throttle plate for that. So this is just for example of what's going inside the pot, and the resistance is putting back as feedback into the ECU to control the throttle. So that would be the stock configuration of how the engine will work without adding any additional components. This down here would be just looking at the speed control circuit of how we want to modify it so it could still use the stock potentiometer and then the remote potentiometer that we're adding. And here, right here, is going to be a toggle switch. So this is a toggle switch I added on the front panel. It's a single pole, so you got the middle is the common. When you're aimed down, it makes contact with the top lead, so it makes circuit going up. When it's pointed up, it makes circuit from the center one going down. So you can pick one or the other. So when we're in the switched up and this yellow green wire makes contact with this pot, so let's say if it's the top one, it'll make contact with the top one, and then the bottom is the swiper. It'll be reading the panel control. So it'll go voltage, you go from here up to this switch through this pot and back, and it'll be referencing whatever position this switch or this pot's going to be at. So if this is the panel control and we want to switch to remote, we flip the switch to the other position. So from the top one we switch it down. We are now reading the yellow green wires making contact with the bottom pot. Let's say this would be the remote pot. Now the feedback of wherever position this is still going to go back. It's the purple is joint with these two, but since it's making contact down here and not with the top one, it doesn't matter what position this one's in. It's just going to read the resistance of what the position this pot's going to be at. So that's where I didn't want to wire just the ECU to the remote pot. I wanted to have, in case the wiring, the throttle got damaged or oxidation or something where the remote stopped functioning, I could flip the toggle switch and still have panel control with the panel with the pot on the panel. And that, you know, you could still either set it at idle and still cruise by, set it at, you know, half RPM, and at least have like a cruise control option. So that's where I wanted to keep some of the stock options, yet try the aftermarket. The component that let us do the remote, it could be as simple as a pot right here, but it still didn't give us the feel for a throttle where you pull it or you do your hand throttle that you'll be able to go max. You still need a spring that kicks it back to low idle. You know, if you let go of your throttle, you want that feel of it going back to idle. So a pot itself won't do that. There's no internal component that would allow for that to happen. So when I did my search, luckily enough, EZGO had a controller box that both had a spring return that will bring it back to idle or back to the max resistance, and it was also internally already had a 5,000 ohm resistor in it. So that's where this component comes to play. This is the PB-6 type throttle control. It is 0 to 5,000 ohm with the micro switch. So you can see here, it's a hefty little piece of machinery with a stainless steel box, and it's plug and play for EZGO, but we'll have to modify these components. So internally of the box there is this shaft, and that shaft is a potentiometer that is 5,000 ohms. So you got this lever that you could go from min to max, but when you go to max, it returns back. So this is going to give you that engine feel, that gasoline return spring feel, and it's also going to give the engine the resistance values for minimum to max when you're minimum throttle and full throttle. So this box is, I believe, was close to $80. The PB-6 is the part number for this style of box. This is aftermarket. 0 to 5K is the resistance. This is the box that made everything work. I was able to mount this onto the engine. I was able to modify this plate so I could put a C clamp for the control cable. liner to work, the guide, and then the cable I tied into this hole right here. So when I pull the throttle, it'll pull this lever. So full throttle, it'll pull it all the way. Half throttle and release, they'll go to idle. So it's a really strong spring, and it gives you really good feel, like if it was if it was throttled by cable all the way through. The response time on the ECU for the resistance is almost identical to a throttle by cable. Like if you would have had any other gas, directly onto the carburetor itself. There's no lag. You can release it and it'll drop down to idle just as quickly as the other setups. These ones you do have 4 wires because it does have a micro switch here. We don't use the micro switch. We could delete that from the circuit. You got 4 wires, so we'll be deleting those 2, and then you'll just have the 2 wires for the pot that you'd wire into the new engine. So we could compare this assembly to what I modified to make it work with the Duromax engine. I did remove this plate, cut off some angles, repositioned it so I could put the retainer for the control cable there. So this would be what this was originally. I did this angle from that same material, drilled the nut so I could have the retainer for the control for the throttle cable. Throttle cable gets held there. I got the cable going through the bottom pin, the best angle that it had. The higher you go, you'll need more throw on your throttle. The lower you go, the less throw you'll need on the throttle to be able to achieve full throttle. So maybe if you use the top position and you pull full throttle, it might only go halfway depending on the throw you have on your lever. So this, like I said, that plate, I got rid of the trigger or the switch. I did the plate so it used the 2 mounting points and drilled so I could mount this holder for the cable. And on the pot, we didn't have to modify anything internally. You got 2 wires here, black and red, coming out. On the original one, you got 2 blacks and 2 reds, but once you remove the trigger and cut the insulation, you'll see which 2 you'll have to cut from or delete from this circuit. I could see this switch being perhaps used in the future if there's ever an electronic clutch that could engage and disengage the output. So if you release the throttle and it hits that switch, it could disengage your output shaft with the electronic clutch. And then as soon as you pull the trigger and it opens and that switch releases, it could engage power to your output. So it'd almost be like an automatic clutch engage and disengage without it having to be an external component. So that switch probably in the E-Z-GO has that purpose of automatically putting a e-brake on or something if you release the pedal. But on this circuit, I haven't seen a need, at least on my engine so far. So from here on the lever, pull the throttle, it'll pull this. That sends the 1 ohm resistance up to 5,000 ohms depending on the position, and that gets sent to the ECU of the unit. So we can look under the hood of this thing now. Alright, so we got the front panel. Ideally, got to pull the air intake cover out. Two 10mm screws. And this cover plate comes out, and this is where most of the electronics could be found. So we got a good look here. So we got the wires or the connector for the on off switch. See a couple wires there. You got the connector for the tachometer cable here, so that sends hours, RPMs while you're running, maintenance hours as well if you wanted to set that timer. And now you got, as you can see, the wiring I added, the toggle switch I added, and the factory pot from the motor. So originally this pot has the purple wire and it has the yellow with the green line wire. So this was the original two wires coming out, and this wire went to this one directly. So you could see the purple, yellow with green used to mate right here. What I added was a T-tap with the red wire from the controller box, that remote controller box. So that gives that purple wire that got the option going from this one to the other remote. And then we got the toggle switch. So this yellow with green is going to be the common, the middle one. So depending on the position of the toggle switch, it's either going to reference the panel or it's going to reference the remote. So it's either going to conduct this way to the remote, flip the switch, it's going to conduct this way to the panel. Either one doesn't, once it's doing the circuit, this one doesn't matter if it's disconnected or whatever position the other one's at. So that's where this toggle switch let us still use the panel or use the remote, and the engine wouldn't know the difference between the two. So that's pretty much the basics of it. I'll do a run test on it in the morning so I won't bother my neighbors. Got a straight pipe on this system, so it's a little on the loud side for this time of night. But I'll do the run test so you guys can see the throttle response as I pull the throttle and what goes there. But for $80 in parts, you're already gonna have the throttle cable assembly. Ideally, if you have a kit and you're installing this engine, you'll just need $80 for the controller. You'll need, just a little overkill in thickness of wiring, but you'll need about 3 feet of 2 wires here. You'll need a toggle switch, which they're under $20 for a 2-position toggle switch. You'll need a T-tap. If you buy a box of 100, it's $10. Pretty much all you would need. So within 100, close to $100 range, you could have the Duromax 999 work as throttle by cable for your system and not have to buy a Mikuni and still try to keep the machine stock and go from there. It's been a great engine, been a great boat overall, and yeah, this video way overdue, but I wanted to make sure everything was working well. There wasn't any options or upgrades that might have been an easier way to achieve the same outcome. But no, this has been working reliably, and that, like I said, the EasyGo controller box, that's the savior right there of making this work. 5,000 ohm pot inside already, throttle, heavy duty throttle system, some mounts right there. I don't know if you could see, already had a 10 millimeter, and then I just put a second screw in the plastic to hold it in place. Okay, let's set up to do the throttle response test. One screw for the drop down handle, that way the boat fit in my garage. Handle drops down. Nice and tight. So now when you lift or lower the handle, it works there. You got the throttle, got the kill switch. I'll go over which wire you need to tie into on the Duromax to make that die. So push the button, turns red, hold the button, gotta hold it for 3 seconds. It'll go through the So this wire is coming from the kill switch, and we will be tying into a T-tap again. Let me open this up for you. And we're tapping in to the factory red and black, which turns into black and red. So I'm tied into the black and red. So grounding out this wire to chassis will kill the engine. So this wire right here, this one's going straight to chassis ground. Solid ground right there. That's one going to the kill switch. And the next one going to the kill switch. On this side, well, I still have the oil pressure switch and everything hooked up. It is the black with the red stripe wire. That's going to be your ignition kill switch. So last thing I gotta say is, if you understood the diagram and how it's functioning, it seems pretty, hopefully it seems easy enough to be able to use this engine for any projects you do have. It's been working great. It, electronics wise, is simple compared to other EFI units I've had that might require more details, more feedbacks that might mess anything up. But on this, it's just reading the same thing from the panel as it is to your throttle. So it's great response on it, and throttle response on it, and there's very easy to bring back to stock if needed. So keep the Duromax 999 as a good option for any of their future projects. Peace.